So next, let's have a look at working memory. Working memory is the ability to hold information active in your mind for periods of a few seconds to tens of seconds, where it's available for immediate further processing. And a major characteristic of working memory is that the number of independent objects that can be held active simultaneously is limited. For example, you can only visually imagine 3 or 4 separate objects at the same time. Imagine a chair. Then, keeping the image of the chair active, imagine a separate cat. Then, keeping the separate chair and cat images active, add an image of a book. Now try to add an image of a pineapple, then a coat, and then a car. It becomes steadily more difficult to hold all the separate visual images in your mind at the same time. Although, by grouping them in some way, for example, imagining the cat sitting on the chair next to a book and scratching a pineapple that's on top of the book with the coat hanging on the back of the chair, can boost the capacity a bit. This grouping is called chunking and is more effective if we can invent a clear interaction between all the members of the group. With chunking, the visual characteristics of the different members are more vague, but those characteristics can be recalled using the group image. Now, once again, it's hard to quantify that type of experience consistently for different people. So there are various tests used in the laboratory to measure working memory, and I'll describe a number of these in turn. The first type of test is list recall, and there are a number of different ways in which this test can be performed. In full list recall, subjects are shown a list of objects, like letters, to examine for a few seconds. Lists can be of different lengths. Lists can be numbers or words. Immediately afterwards, the test subjects are asked to report the objects in any order. Now, subjects make errors. They may miss an item or less often put in an item that's not there. Each subject is tested using lots of lists of each length, and one way to evaluate the results is to determine the length of list that a subject gets completely right half the time. For the average subject, this is 7 numbers or 4 to 5 random words or letters. The other approach is to determine the longest list that a subject gets right 100% of the time. For different subjects, this number is either 3 or 4, although it can be shorter for brain-damaged subjects. This smaller number is important because it probably reflects the capacity of working memory in the absence of any chunking. In another version of the test, subjects are shown longer lists and immediately afterwards asked to recall as many as possible. Normal subjects show an enhanced recall for the last few items on the list. This is called the recency effect, and it's an aspect of working memory. Normal subjects also show enhanced recall for the first few items on the list. This is called the primacy effect, and it seems to be dependent on decorative memory because it's not present in brain-damaged patients who've lost the ability to create decorative memories. If there's a semantic connection between the words on the list, more can be recalled. And in the extreme, 15 or 20 words in a meaningful sentence, which is, once again, an example of chunking. It's the groups of words rather than the individual words that are actually recalled. Another kind of experiment is short-term forgetting. Here, subjects are asked to keep 3 consonants in mind. But after hearing the consonants, they also hear a 3-digit number. And then they're asked to count aloud, starting from that number and subtracting 3 from the number each time, while still trying to keep the original consonants in mind. After counting for a period that's varied between a couple of seconds and about 20 seconds, they're asked to repeat the original consonants. The ability to recall the consonants declines with time, and it's generally completely gone after about 5 seconds. A third type of working memory test is visual memory span. In one version of the test, subjects are shown a group of objects very briefly, perhaps 100 to 200 milliseconds, and immediately afterwards asked to name all the objects they can remember. Subjects can typically remember 4 or 5 objects. In another version of the test, subjects are shown a randomly arranged group of identical objects, again very briefly, and asked to determine how many objects are present. Subjects can correctly identify group sizes up to about 6. Another test aimed at measuring visual working memory is called pattern matrix testing. In this test, subjects are shown a matrix of rectangles. Some are filled in and some are empty. After a few seconds, the matrix is removed and they're given a blank matrix, and they're asked to fill in the rectangles that were black in the earlier image. They're trying to reproduce the earlier matrix. For a range of different sized matrices, it's found that about 9 fill blocks is the memory limit. It's also possible to investigate working memory for muscle movements. In the Corsi blocks test, 9 wooden blocks are arranged randomly on a board, and the subject watches the performance of a sequence of taps on the blocks. The subject is asked to immediately reproduce the sequence. Sequences are from 2 to 8 taps, and normal subjects can accurately reproduce sequences of up to 5 or 6 taps. Now, we talked about 3 different approaches to measuring what we're calling working memory: verbal, more purely visual, and memory for movements. It turns out that these 3 types operate independently to some degree. If some verbal task is required while trying to remember a matrix pattern, it has little effect. But if the same verbal task is given while trying to remember a list, it degrades the memory capability. On the other hand, a visual task degrades pattern matrix performance, but not the list recall tasks. And there's a similar dissociation between visual and movement working memories. A visual task reduces performance on pattern matrix, but not Corsi blocks, while a movement task reduces performance on Corsi blocks, but not pattern matrix. So these dissociations suggest that there are separate brain resources being used for the different types of working memories. And as for semantic memory, there's a widely known model for working memory. But again, the problem is defining the anatomical and physiological mechanisms that support the different functions of this kind of model.